Okay, what we're looking at tonight, it's a Analogic model AN3100 DC voltage standard. This DC voltage standard is portable. It heats up very quickly in about 10 minutes and provides precision DC voltages from in 100 microvolt steps, increments, all the way up to about 11.11 volts. It's portable and it works very well, very clean output out of it, and wonderful for calibrating meters, for testing scopes, anywhere where you'd need a standard voltage applied. And give you a look at this. We have right now the output is on a B&K scope, and I will put the output on the absolute lowest position. Alright, we are on 5 millivolts per division, and I do have the standard is on. My probe is on ×1 position, so I am feeding a signal directly into the scope. And on my most sensitive setting, I cannot see an observable disturbance on this line. It's clean. And I can change the frequency, it really doesn't matter. Alright. So, let's, there's nothing to lock to, so I'm going to take her so that she's not locked on the trigger. And then we're going to, just to show you that we are reacting to the standard calibrator, let's go ahead and manipulate an input here. Here we go to, we'll go to 1 millivolt. Alright, now we are on 5 millivolts per division, and we just went up 1/5 of a division, so that's 1 millivolt. Here's 2, 3, 4, 5. So as you can see, we were stepping up a division at a time. It's beautiful, working very well. Okay, we're going to go ahead and switch to using a digital voltmeter so that you can observe the voltage readings. And now that we've seen the cleanliness of the signal, that's really the majority of the reason why you'd look at it on the scope. Okay, we have the output of the Fluke 343A DC voltage calibrator at 10 volts, and we're going into our Keithley 177, and we show 10.000, so 10 to the millivolt. Now let's transfer our leads from the Fluke to the Analogic, which is also set right now to 9.9999 or 10 volts. And we are reading 9.999 or 10 volts. So we are right there. So the Fluke and the Analogic were outputting 10 volts to the millivolt. Now let's step this Analogic down. Now that we know that it was measuring or providing 10 volts output, likely providing 10 volts output as guaranteed by the Keithley and the Fluke. Now let's step this thing down. We'll go from 10 volts to 9 volts to 8 volts. 7, 6, 5, 4, 3, 2, 1. Okay. Now we go 0.9, 0.8, 0.7, 6, 5, 4, 3, 2, 1. Alright. Then we go to 0.09, 8, 7, 6, 5, 4, 3, 2, 1, and then 0.009, 8, 7, 6, 5, 4, 3, 2, 1. And then finally, in a range you cannot see, I can take it down. Well, let's change range. Alright, we go 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Alright, we've gone from 10 volts all the way down to 0 volts, and with a resolution finally of 100 microvolts. We went 100 microvolt steps right down to 0. And as you saw, we were perfectly linear on our meter. So our Analogic's doing a beautiful job here. It's easy to read the numbers, easy to dial it in. We also have an offset dial where we can raise or lower, make a difference of plus or minus a millivolt if we were trying to take care of an offset or nonlinearity or something. Or you can push it in, which it's in right now, and that takes the base calibration of the unit. There is no zero calibration for the unit. It's inherent in its design. It's supposed to be less than 50 microvolts maximum, and I was getting 15 to 20 microvolts of offset for 0, which puts it below the 100 microvolt step, so we know we're there. So the unit was repaired. One of the dials had been broken and has been super glued. It's actually this 1/10 of a volt dial. If you look, you won't be able to see it, but it's been glued and repaired and is perfectly fine now. You can read all of the digits all the way up. And then on top of that, there was a burnout, or actually broken neon bulb in this particular display. I replaced the neon bulb, and we had a missing foot, and I have replaced the missing foot. So on top of that, the switch was broken, so I bought a new switch and went through quite a time getting the switch to be lighted, but came up with a novel way to handle that problem without affecting the circuit whatsoever. And as you can see, the unit works fine, switches on and off just fine. One of its hallmarks is that it warms up in about 10 minutes to provide you highly accurate readings. Actually, it's rated readings. And there's only one calibration point in it, one pot that's calibrated for 10.0000 volts when you have a standard attached to it. That's been done. Everything on this is, the case is in marvelous shape. There are no major scratches, no major abrasions. It actually looks very new. It also has on its backside a millivolt output. You can output the 0 to 11 volts from the front panel. In the back here, it's 0 to 111 millivolts instead of volts, as is on the front panel. And along with that, I have a marvelous manual that'll be provided. Now this reads a Data Precision Model 8100, but as you note here, it also says an AN3100. Analogic was obtained by Data Precision, or it's actually a division of Analogic. Data Precision is a division of Analogic. So the AN3100 and the Model 8100 are one and the same. We have the manual here. It takes you through its theory of operation, gives you its specifications, picture of the unit, and then takes you right through maintenance of the unit. It's and then provides a number of parts lists and schematics, foldouts. Beautiful schematic right here. So you've got everything you need to utilize, keep it running. It's a beautiful unit. It's working marvelously. It'll give you a wonderful standard for your bench, probably far better than 99% of you have. I wish you luck. I think you'll enjoy it. I know I've enjoyed having it. I'd have actually put more money into some more expensive units now and have less of a need for this, so I'm selling it. Pay off my other equipment. So thank you for listening, and happy bidding.